Good evening, everyone. Welcome to the Aquarium of the Pacific. I'm Jerry Schubel, president of the Aquarium. We're sorry you can't be here in person, but we're glad that you're all at home taking care of yourselves and watching this lecture this evening. I want to acknowledge our lecture sponsors, Gazette Newspapers, and the Courtyard Marriott. Tonight, Dr. Richard Somerville will present a lecture to discuss the latest climate science and public perceptions and how science can guide and inform policy making. Dr. Somerville is a distinguished professor emeritus at the Scripps Institution of Oceanography, the University of California, San Diego. He earned his Ph.D. from New York University, and he has received awards both for his scientific contributions and for his popular book, The Forgiving Air and Understanding Environmental Change. He has published more than 200 papers, and he was one of the coordinating lead authors of the Working Group 1 for the 4th assessment report of the Intergovernmental Panel on Climate Change. He's a fellow of the American Association for the Advancement of Science and the American Meteorological Society, and he's made not only major contributions to fundamental science and our understanding of climate change, but he's crossed that barrier that separates policy from science, and it takes a lot of courage for scientists to cross that barrier, and we're very fortunate that he has. He was one of the founders and the authors of the Bali Climate Declaration, in which 200 scientists from 20 countries signed on to what we know about climate change and what we need to do about it. And he was also one of the founders and signers of the Copenhagen Diagnosis, which brought together 26 climate scientists from 8 different countries. And he really has made fundamental contributions to our understanding of climate science. He's translated those into terms that the general public can understand, and as I say, he's crossed that barrier into the policy arena as effectively as anyone I know of. Please join me. You've got a virtual hand clap for our speaker, Dr. Richard Somerville. Richard?
Thank you very much, Dr. Jerry Schubel, and it's a great pleasure and an honor to be here. In this talk, I have both facts and opinions. I'll first summarize the facts that we've learned from the science of climate change, and then I'll give some opinions about what people and government should do. Everyone is entitled to his own opinion, but not to his own facts. Daniel Patrick Moynihan, who said this, was a wise and accomplished American politician, sociologist, and diplomat. Some 2,000 years ago, another wise person, a great Jewish leader named Hillel, gave a fine example of how to say a lot in a few words. Hillel was confronted by a skeptic who asked for an explanation of the 5 books of the Torah. These books are sacred Jewish scriptures, known to Christians as the first 5 books of the Old Testament. There are many long analyses of these 5 books. The skeptic, however, demanded from Hillel an explanation so brief that it could be spoken while standing on one foot. Hillel lifted a foot and said, "Treat others as you would wish them to treat you." That is the entire Torah. The rest is commentary. Now go and study. I think any rational response to climate change involves first knowing what the facts and evidence are. That is the province of science. We should all learn and accept the facts and evidence, which are objective truth and should be the same for everyone. Moynihan was right. Nobody is entitled to his own so-called facts. The best summary of climate change science is the assessment reports of the Intergovernmental Panel on Climate Change, or IPCC. 5 such reports have been published since 1990, and a 6th is expected in 2021. The physical science portion of the most recent IPCC report is scientifically definitive, but it is long, about 1,500 pages, full of charts and graphs, and not easy reading. Now, I am certainly not Hillel. Science is obviously not religion, and the IPCC reports are not the Torah. Nevertheless, I think the essence of the most recent IPCC assessment report can be summarized in 12 succinct points. These are just my own professional opinions, not an official IPCC product. They all fit on one slide. Here they are. It's warming. It's us. It hasn't stopped. The heat is mainly in the sea. Sea level is rising. Ice is shrinking. Carbon dioxide, CO2, makes oceans more acidic. CO2 in the air is up 45% since the 1800s. It's now the highest in millions of years. Cumulative emissions set the warming. Reducing emissions limits the warming. Climate change will last for centuries. Just 12 points, only 60 words. You can easily speak them while standing on one foot. One could say much more about each of these 12 points. To start, here are some important facts. These are just some of the indicators measured globally over many decades that show that the Earth's climate is warming. White arrows pointing upward indicate increasing trends. Black arrows pointing downward indicate decreasing trends. All the indicators expected to increase in a warming world are increasing, and all those expected to decrease in a warming world are decreasing. It's definitely warming. It's not a hoax. We observe it and measure it. The atmosphere is warming, so is the ocean. Sea level is rising. Ice sheets and glaciers and snow cover are shrinking. The amount of water vapor in the atmosphere is increasing. Climate change is real and serious. It's not a remote threat for the distant future. It's here and now. It's us. We've done the detective work. Just as wildfire experts can say whether a fire was caused by lightning, or by a campfire accidentally left burning, or by arson, we can show what is now causing the world to warm. Yes, some past climate change was natural, like ice ages coming and going. But the warming we have observed in recent decades is clearly caused by human activities. The evidence for that is overwhelming. We now know what paces the beginnings and ends of ice ages. It is slow changes in the Earth's orbit around the sun that alter how sunlight is distributed over the surface of the Earth. We understand these changes in the orbit, and they take thousands of years to have an effect. They cannot possibly produce the climate changes that we observed occurring in just a few decades. Similarly, we can rule out other natural processes, such as changes in the energy in sunlight. We measure them, and they are quantitatively too small. Human activities, such as burning coal and oil and natural gas, are the dominant cause of the rapid climate change we now observe. It hasn't stopped. The warming is still continuing. This graph shows the global average temperature of the Earth's surface from 1880 on the left until the present on the right. 1880 is about the time when we first had enough good thermometers located in enough places around the Earth to enable us to calculate a meaningful global average. For about the last 50 years, from the 1970s until now, we see there has been a warming of about 1 degree Celsius, or 1.8 degrees Fahrenheit. All the warmest years on record are recent years. The heat is mainly in the sea. Over 90% of the heat added to the climate system is in the oceans. This graph shows the heat content of the upper ocean since 1960 on the left. The red line shows the more detailed data that we have in recent years on the right. How do we measure the heat stored in the ocean? That's fascinating. We now measure this increase in ocean heat content from an array of about 4,000 autonomous floats deployed throughout the world ocean under an international program called Argo. They have no engines and no propellers, but these floats move with the ocean currents at a depth of about 1,000 meters, which is about 10 football fields end to end. That's the depth where they are usually parked. And these floats are programmed to periodically sink another 1,000 meters lower in the ocean and then rise to the surface slowly while measuring quantities such as the water temperature and salinity. They rise and sink by changing their volume. This is accomplished by pumping fluid into or out of a bladder on the float. The floats store the measurements, and then when they're on the surface, They locate by GPS, and they transmit the stored data via satellites to scientists. The change in float locations between one transmission and the next provides information on the currents at the depth where the floats were parked. As their batteries fail, the floats end their useful lives and must be replaced by new floats. The Argo floats have revolutionized our ability to observe the oceans, and Argo data are available to everyone for free in near real time. New floats, allowing sampling to much greater depths, are being developed. Sea level is rising globally. We measure it from altimeters on satellites. On this graph, you can see a rise of 100 millimeters, which is about 4 inches, over the last 30 years or so. The rate of sea level rise is increasing too. Future sea level rise will be much greater than past sea level rise. The sea level rise plotted here is the global average, but the amount is different at different locations on the Earth. Local sea level is affected by whether the land at that location is rising or sinking, and also by ocean currents, tides, and other factors. Ice is shrinking. Ice sheets on Greenland and Antarctica and almost every glacier worldwide are all shrinking. The break in the graph at the lower right in 2018 occurred when the satellite mission called GRACE terminated its scientific operations and was replaced the next year by a GRACE follow-on satellite mission. These satellites determine the mass of the ice accurately by measuring the effect of the ice sheet on the Earth's gravity. The technology of the GRACE missions involves 2 satellites in the same orbit, which have a means of measuring the distance between the 2 satellites extremely accurately. This distance changes when gravity varies, which occurs when passing over ice sheets. And measuring the tiny change in the intersatellite distance allows scientists to determine the mass of the ice. Carbon dioxide absorbed by the ocean makes it more nearly acidic. That can affect the marine ecosystem and the food chain. Here, the red line is known as the Keeling curve. It's the most famous graph in all of Earth science. It shows the carefully measured increase in atmospheric carbon dioxide, CO2, from 1958 on the left to the present on the right. The ocean absorbs some of the CO2 that we emit into the atmosphere. The green line on the lower right portion of this figure thus shows the acidity parameter called pH decreasing. Seawater is slightly basic. Its pH is greater than 7, and we see in the decreasing green line a shift toward neutral conditions, pH equals exactly 7, rather than to truly acidic conditions, pH less than 7. Carbon dioxide amounts in the atmosphere, because of human activities, are now about 45% higher than they were in the early 1800s. This graph shows atmospheric CO2 amounts over the last 800,000 years. 800,000 years ago is on the left, the present is on the right. These data come from analyzing fossil air trapped in ice in Greenland and Antarctica. The large variations in CO2 amounts are associated with ice ages starting and ending. The nearly vertical line at the right-hand end of the graph shows the rapid recent increase in atmospheric CO2 amounts due to human activities, chiefly burning fossil fuels, coal and oil and natural gas. The amount of carbon dioxide in the atmosphere now is the highest it has been in millions of years. The atmospheric CO2 amounts, even in the more distant geological past, many million years ago, sometimes have been higher than at present, but the world was a very different place then, and it was long before any human beings existed. Cumulative emissions of carbon dioxide set the amount of warming. The blue bars on this graph, based on extensive research, show that warming caused by CO2 is, to a good approximation, just linearly proportional to the total cumulative amount of carbon emitted into the atmosphere. The whiskers, or error bars, the black lines on top of the blue bars, show the IPCC range of possible sensitivities. That is, the range of carbon emitted in trillions of metric tons on the vertical axis for a given amount of warming on the horizontal axis. For the middle of the range, the second blue bar from the left shows 1 trillion metric tons of carbon emitted produces a warming of about 2 degrees Celsius above the temperatures of the early 1800s. The dashed horizontal line shows that we've already emitted about half of this amount. Now, at present, the warming we observe is caused by CO2 plus several other heat-trapping substances which human activities have also added to the atmosphere. However, the amounts in the atmosphere of those other substances will decrease rapidly when their sources are eliminated, but some of the carbon dioxide will remain in the atmosphere for thousands of years. Because of the difference in the amount of time the different heat and trapping substances stay in the atmosphere, carbon dioxide is truly the key control knob for climate. Reducing emissions of carbon dioxide and other heat-trapping substances will limit the warming. This graph was produced in 2009, and it shows three possible trajectories of warming reductions. The area under the three curves is the same, and it is an estimate of the cumulative amount of carbon emitted that would give us a 2 out of 3 chance of limiting warming to 2 degrees Celsius, that's 3.6 degrees Fahrenheit, above the pre-industrial temperatures of the early 1800s. The green curve shows that if emissions had peaked and began to decline in 2011, then emissions reductions could be gradual. And by 2050, emissions would still not need to have entirely stopped. The blue middle curve shows that if emissions peak and the beginning of emissions reductions did not occur until 2015, reductions would need to be much greater. And the red curve shows that if reductions did not begin until 2020, drastic reductions would have to occur quickly and reach zero by 2040. This graph illustrates the urgency of acting. 2 degrees Celsius is the warming target set by the Paris Agreement signed in 2015. The longer we wait before acting, the more drastic the action has to be. The result of failing to act is to increase the likelihood of dangerous climate change. Because it takes so long for the carbon dioxide in the atmosphere to decrease, climate change will last for centuries. This graph shows that after emissions completely stop, that's on the far left, the amount of carbon dioxide in the atmosphere decreases only slowly for several centuries, and at about 25% of it remains in the atmosphere for the next 10,000 years or so. The science relevant to this topic is not simple. Several complex processes for carbon removal are involved. The lines on the graph are results from different climate models. But the key takeaway message is that the climate change caused by adding carbon dioxide to the atmosphere can have very long-lasting effects. Finding a way of removing some of the carbon dioxide is one approach to geoengineering. Here, by geoengineering, we mean the intentional modification of the climate system with the goal of reducing or mitigating climate change. However, nobody has yet demonstrated a way of economically removing large amounts of carbon dioxide from the atmosphere. Here they are again, 12 key findings of climate science, only 60 words. You can easily say them while standing on one foot. These are facts. They are fundamental findings from extensive scientific research. They are all well supported by abundant evidence. As Hillel said, the rest is commentary. Now go and study. The science is never complete. There's always more to learn. But the science that we have now is already good enough to help us make wise decisions. The many unknowns in the science, such as exactly how fast the Antarctic ice sheet will shrink or exactly how El Nino might be affected, are not the biggest unknowns about future climate. The biggest unknown about future climate is human behavior. Everything depends on what people and their governments do. These computer projections show that with lower global emissions of heat-trapping gases, that's the map on the left, we can limit US warming late in this century to about half of what it would be if we continue to rely on fossil fuels for the world's energy. That's the map on the right. The choice is up to us. The scientific consensus is overwhelming. Climate change is already happening here and now. About 97% of climate experts, the scientists who are most active in carrying out and publishing research on climate change, agree that the observed recent warming is real and serious and overwhelmingly human caused, and that it will become even more serious unless we make big changes in how we generate energy. Nevertheless, some people remain unconvinced. They continue to repeat climate myths and falsehoods. People often ask me, I'm only one person. What can I do about climate change? And here's my answer. We need to persuade more people that this problem is serious. Governments tend to respond when enough people become concerned and when they vote their concerns. I urge each of you to engage with people you may know, family, friends, colleagues, who don't accept the fundamental findings of climate science. Explain to them what you have learned about our changing climate. Listen to them respectfully and carefully. Be alert to the common climate myths and falsehoods that they may think are true. If you see something, say something. Have a civil conversation. Have many conversations. In their hearts, almost all of us would surely agree that everybody is entitled to his own opinions, but not to his own facts. And it is science that supplies the facts about climate change. The biggest unknown about future climate is human behavior. Everything depends on what people and their governments do. We humans have become the dominant actors in causing the rapid climate change we now observe. Human actions now overwhelm all the natural processes. This may seem counterintuitive, but it's true. You and I, and all the people who are alive today, now have our hands on the thermostat that controls the climate of our children and grandchildren. Metaphors can be superb communication tools. The thermostat is a powerful metaphor. Think about medical metaphors. Here are a few. We climate scientists are planetary physicians. Climate science and medical science will both always be imperfect and incomplete, but both are already very useful. When your doctor tells you to stop smoking and lose weight and exercise more, you don't argue with her. You don't call her a radical alarmist. You don't ask her to name the date when you will have your heart attack. Physicians have advanced academic credentials and many years of training and experience. We climate scientists have the same. We're not conspiring to fool people. Do you really think your doctor is a crook? She's not, and neither are we. A fever of only a few degrees can indicate a serious disease. Global warming is just a symptom of planetary ill health, like a fever. Prevention is better than cure. Quitting smoking, like quitting using fossil fuels, is not easy to do, and the main benefits of quitting come in the long term. Choosing to have major surgery involves cost and risk, but people know that choosing to do nothing also has costs and risks. The laws of climate science and medical science are all immune from political tampering. You can't fool Mother Nature, and Mother Nature always bats last. Here's a good metaphor. Imagine you're watching a Major League Baseball game. The slugger who's thought to be on performance-enhancing drugs hits a home run. The person next to you asks, did the steroids cause it? That's really the wrong question. You can't be sure they caused it because he was already a big league slugger back when he was clean. And even with the drugs, he can still strike out now and then. But at the end of the season, you see in his statistics that he hit more homers than he used to. The steroids increase the odds of home runs. Climate is the statistics of weather, and carbon dioxide is the steroids of climate. It changes the odds. The odds are higher now for all sorts of extreme weather because climate change has altered the environment in which all weather occurs. This metaphor works for other sports too. For example, baseball isn't popular in France, but bicycle racing is very popular there. And French people know that a bike racer on drugs won't win every race, but the drugs do change the odds and increase his probability of winning. The main barriers to action are a lack of widespread political will and a lack of wise and inspiring leadership. Science can help to inform policy, but only concerned people and responsive, capable governments can first decide what policies are best and then implement them. Today, despite a strong scientific consensus, climate change is controversial politically. We do not have to accept a future with devastating climate change and disruption. The biggest unknown about future climate is human behavior. Everything depends on what people and their governments do. If we continue to use more and more fossil fuels to generate the world's energy, we will be sentencing our children and grandchildren to many centuries with a severely damaged climate and great suffering. In your conversations, try to help people understand that this bleak future is entirely preventable. Faced with these threats, almost all the nations of the world agreed in Paris in late 2015 to limit the warming to a specific maximum amount. That amount is 2 degrees Celsius, or 3.6 degrees Fahrenheit, above the average global temperature in the early 1800s, before human activities began to have a large effect. After Paris, is the glass half empty or half full? I am guardedly optimistic. World leaders are now engaged, at least almost all of them are. Emissions of heat-trapping gases have begun to decline in some places. Solar and wind energy are getting cheaper every year. Renewable energy use is increasing rapidly. Many corporations are now acting to reduce emissions. States and localities in the US are acting too, despite federal inaction. And many other countries are showing rapid progress. Recent polling shows that in the United States, many more people accept the science and are very concerned about global warming or climate change than was the case only a few years ago. However, it's extremely partisan. The increase from 2008 on the left and to 2020 on the right in the number of people calling climate change or global warming a top priority has been limited to the Democratic side of the political spectrum, as shown by the blue lines in this recent poll from the Pew Research Center. In 2008, 47% of Democrats called climate change a top priority. In 2020, that number had increased to 78%. In 2008, 15% of Republicans called climate change a top priority. And in 2020, that number had increased only 6 points to 21%. Thus, about 4 out of 5 Republicans, including virtually the entire leadership of the Republican Party, still reject the science today. We have a long way to go. I think we should keep climate change science separated from climate change policy. Everybody is entitled to his own opinions, but not to his own facts. There is no silver bullet that solves all the challenges of climate change, but there is lots of silver buckshot, including increased energy efficiency and energy conservation, and much more use of sun, wind, and water to provide the energy the world needs. These renewable resources are widely available now and are already cost competitive with fossil fuels. We have the technology, and it's improving. In the United States, even without energetic action by the federal government, I am guardedly optimistic. Market forces now favor carbon-free energy. Coal companies are going bankrupt. Solar and wind energy without subsidies are in many cases already cheaper than fossil fuels. Electric vehicles are happening fast. And much energy policy in the US is set at state and local levels, not in Washington, D.C. One last time, always remember why we want to have conversations about climate change science. We want to inform people, we want to motivate them, we want them to act. The biggest unknown about future climate is human behavior. Everything depends on what people and their governments do. Research suggests that messages that may invoke fear or dismay are better received if they also include hopeful messages. We should include positive messages about our ability to solve the problem. We can explain that future climate is in our hands. Politics and priorities and values do have a role to play in deciding which actions are best. But any rational policy begins by accepting the science. People are entitled to their own opinions, but not to their own facts. This talk is being given in May 2020 And I have a few gentle words to say about some climate change lessons that we might learn from the coronavirus pandemic, which is now gripping the entire world. One obvious point is that climate change science, like coronavirus epidemiology, is incomplete, still developing, but already extremely useful. In both domains, we have learned that we can trust scientists more than politicians or pundits or anybody else who is not really an expert on the science of the subject, whether the subject is climate change or infectious diseases. We have also learned that the challenges in both climate change and the pandemic are global. The entire world is affected. The solutions have to be global too. The pandemic also illustrates the wisdom of the statement that everybody's entitled to his own opinions, but not to his own facts. The facts about climate change and about COVID-19 are objective truth, and they should be the same for everybody, regardless of people's ideology or politics. When it comes to making policy, sound science can inform wise policy. However, policy can also depend on many other factors, such as people's priorities, their convictions about economics, what they regard as the proper role of governments, their risk tolerance, and of course, public opinion. That's true for meeting the challenge of climate change, just as for meeting the challenge of COVID-19. The pandemic reminds us how valuable science and scientists are. The recent discussions in the news, such as about how clinical trials of drugs and vaccines work, are very educational. The medical scientists who develop new medicines do their best to make sure that they are safe and effective, and they won't release them for widespread use to the public until they are absolutely convinced of that. They are real experts, and they are very careful. So are climate scientists. Dr. Tony Fauci, who has been on television a lot recently, is a good example of a person who is a real expert on pandemics. He says simply, "I'm a physician and a scientist." People get that. When Dr. Fauci speaks to the public, he's not trying to be popular or make people happy or brag about himself or make money. He's just telling people the facts that scientists have discovered. And he describes these facts in a way that is honest and transparent and understandable. He has spent his entire career accumulating expertise and experience and wisdom about infectious diseases and pandemics. People should trust him. And polls show that the great majority of people do trust him. Science is absolutely essential. That's true for pandemics, and it's also true for climate change. After preparing this talk, I watched Warren Buffett's annual Berkshire Hathaway stockholders meeting online. Warren Buffett, the brilliant investor and one of the richest people in the world, agrees with me. Here's what he said, quote, "I think personally, I feel extraordinarily good about being able to listen to Dr. Fauci, who I had never heard of a year ago. But I think we're very, very fortunate as a country to have somebody at 79 years of age who appears to be able to work 24 hours a day and keep a good humor about him and communicate in a very, very straightforward manner about fairly complex subjects and tell you when he knows something and when he doesn't know something. So I'm not going to talk about any political figures at all, or our politics generally this afternoon, but I do feel that I owe a huge debt of gratitude to Dr. Fauci for educating and informing me, actually along with my friend Bill Gates too, as to what's going on. I know I get it from a straight shooter when I get it from either one of those. So thank you, Dr. Fauci," unquote. Amen. Thank you all.
Richard, thank you for a terrific talk. I think you did a marvelous job of summarizing what we know about climate science, what we need to do about it. I think there's something important embedded in all this, and that has to do with consensus among scientists who have particular expertise, whether it's in climate science or in epidemiology. They have to have expertise within that domain. And the IPCC, your Bali Climate Declaration, or the Copenhagen Diagnosis, all of those had a strong consensus among experts about what the science tells us. And too often, we have people who cherry pick a few facts to meet their own needs, and it can get us into trouble, particularly if those scientists are in the government. Say a word about the importance of consensus.
Well, I think consensus is key, Jerry, because when we say that science has proven that, say, HIV causes AIDS, we mean that the great majority of the experts in that domain have come to that conclusion. Science is a group activity, and you can always find an outlier. There are outliers in every field of science that disagree with the consensus. And people sometimes say, well, I think, look, Galileo was right. He upset the consensus. That's true. But, you know, Galileos are very rare, and most people who think they're Galileo are very badly mistaken. If you want to know what science knows about something, the way to find out is to essentially poll the experts. And when they're in agreement, the chances are that you have a solidly founded result that's well founded on facts and evidence.
And so when you're going to set policy at any governmental level, local, state, federal, you better have the consensus of the experts behind you before you formulate that policy.
Yes, I think that's right. And as I've said, other things go into policy. Economics plays a role. Public opinion plays a role. Priorities and values play a role. And Dr. Fauci's been eloquent on that point. He says, I'm a scientist and a physician and a public health official. I'm not giving anybody advice on how to get the country's economics going. I'm telling you what public health and medical science have to say about it. And I think that's the same thing. I don't tell people what kind of policies they ought to make to decrease the reliance on fossil fuels and to move the energy system towards renewables. I think that requires people who are experts in many areas. My expertise is in the science of climate change, and I like to stick to what I know.
And I commend you for that, and you always do. So when politicians or governmental officials at any level say that this has been developed using the best available science, that's got to be a consensus statement if it's to have any validity. Otherwise, it increases the distrust of science and policy making. Yes, I think that's right. I've testified before Congress, and I think the worst aspects of that are when you face people in Congress who have their mind made up, and they are basically attacking you to gain points with their constituents, but without being interested at all in what you have to say. This is just political theater with scientists as props. And a former colleague of yours now at Harvard who wrote this wonderful book, Why Trust Science, Naomi Oreskes. And if this pandemic hadn't happened, you were going to be part of a forum that was entitled When Science Isn't Enough. And we were going to, Naomi was part of it, you were part of it, and we were going to look at some areas. Climate change was one, offshore aquaculture was another, vaccinations, and nuclear energy and some others. I'm hoping we're still going to be able to do that when this all passes and that you will be able to be part of that. I hope so, too. Do you have any last words you would like to say, Richard? Well, I think it helps. I've advised people to have conversations, to engage with the people whom they know, and to try to gently educate them. And I think it helps to get familiar with some of the climate myths and falsehoods. There's a website called skepticalscience.com that does a good job of laying them out and refuting them, saying what's wrong with them. When somebody says this warming is just caused by a change in the sun, well, there's evidence otherwise. We measure the emissions of energy from the sun. They've not been rising, and it doesn't hold water. So science is quantitative. It requires numbers. And I think memorizing the numbers is one thing, but having a good understanding of the facts and how they're established, how we know this or that, is very helpful when you try to persuade members of your circle as to what the truth is. And I think with your list of 12 items there, it's getting warmer, sea level is rising, et cetera, I think it would be very useful to go through that and indicate what the range of projections are and where the center of gravity might be. Right now in California, we're wrestling with sea level rise and this so-called managed retreat. And this is a very pressing issue. It involves science, it involves economics, it involves people's lives and livelihoods. And people tend to pick a number within the projection that best suits what their position is.
Well, that's right. And cherry picking the data is never a good idea. And we already have evidence in Miami, among other places, that sea level rise is no joke. It's happening here and now. We've got salt water moving into freshwater aquifers, and we have flooding happening at low-lying areas. And that's not going to get better by itself. And, if you leave climate change unmitigated, if you don't do anything about it, you're really talking about abandoning much of the coastal world. You cannot build enough seawalls around every city that's on a coast. And so we're talking about something that's very serious. And as I've said, there's an urgency to this. We still have a window to do things, but the window doesn't stay open forever. So you have to stop dithering and procrastinating and decide to act.
And I think the other point to add to all this is we have to act. There's an urgency, but let's combine some hope that if we do act, things could be better the way you suggested. If it's one thing...
absolutely convinced of that. Things can be much better than the way they are.
And I think that's a good place to end it. And the other one with what we've learned, I think, from this pandemic is that to solve the pandemic and to solve climate change, these are global problems, and they will be solved only by global cooperation and global initiatives.
Yes, that's quite right. The carbon dioxide that traps the heat, that increases the greenhouse effect, is blown all over the world by the winds. So all the countries have to suffer the consequences, even though some of the countries did very little toward causing the problem. And so the world has to participate in a unified and organized way to get a handle on this problem and to prevent the most dangerous and severe climate damage.
And with the pandemic, I think that we need the World Health Organization, and we should stop bashing it and help try to make it better.
Absolutely. I'm not an expert on public health, but that seems pretty straightforward and pretty obvious.
Richard, thank you again for a terrific lecture. Stay well, and we'll have you back again. Bye.
Thank you. Thanks very much.
Good night, everyone.
Bye-bye.
We hope that we will see you on June 4th. Douglas Fenner is going to discuss the health of coral reefs in the Pacific Ocean. And although we aren't open to the public yet, you can follow us on our online activity, online academy, and see what's going on. And please join us for our next lecture. Good night, Richard, and good night to everyone.